If the Lagrangian of a dynamical system in two dimension, so it is a two-dimensional system, and its Lagrangian is L is equal to half of m x dot square plus m x dot y dot, then a Hamiltonian. It calculate the Hamiltonian. So the Lagrangian is given, and it is m of m divided by 2 x dot square plus m of x dot y dot. So the px will be, and we have it is a two-dimensional, so the x and y are the coordinates. So the px, the momentum px is equal to del L divided by dou x dot, and we are taking the partial derivative with respect to x dot. M divided by 2 is a constant, and x dot square will be 2x dot, and m y dot is a constant, and x dot will become 1. So with respect to px, this will be the answer, and it cancel out the 2. M of x dot plus m of y dot will be the px, and the py will be, what happens, the taking the partial derivative dou L with respect to dou y dot, dou L with respect to dou y dot, and m divided by, here there is no y dot, it will be 0, and m of x dot will be constant, and y dot will be 1. So m times x dot, so the x dot will be the p divided by m. So replacing the because in the question it's all in the terms of px py, so replacing the x dot here by this py divided by m, and cancel out the m's on both of the terms. It will be px minus py divided by m is equal to y dot, and it's given here. Substituting the x dot in the in this equation, so the y dot will be reduced to px minus py divided by m. So the Hamiltonian will be x of px, x dot plus x dot times px plus y dot times py minus l, and the Lagrangian will be replaced by this, and the x dot and y dot are replaced by these terms. So we'll be obtain these, and by simplifying the all the terms, substituting the x dot and y dot by this, will be obtain this. So simplifying will be obtain this as the answer. So the option C is the correct answer.